Hello and welcome back to another tutorial. I'm Michael and today we will take a look on sprites and sprite movement. Now you may know things like Golden Axe or Streets of Rage. And we will basically implement such a system into our Unreal project. So first off, press on this big yellow button here. It's called Starten because I have a German version. And it is called something different like launch or start. So just click on this big yellow button and it will start our project browser. Now you will need to get used to waiting on the Unreal Engine because it's a big engine and it needs to initialize a lot of stuff. So when it is done loading, I can continue explaining. Okay, now when it's done loading, you will need to go to the new project tab, select it, and then select the 2D side scroller. Don't confuse it with the side scroller here, because this 3D side scroller is just meant for 3D environments and not for sprite based environments. So we will use the 2D side scroller, which will also have a sprite based tool inside of it, and I think it's, if you want to aim for a sprite based game, it is better to use the 2D side scroller with the paper 2D technology in it. So just click on it, give it a random name like test sprite, test sprites then, and click on create project. So we will wait again and let's see what happens when we actually open the project, which will be in a moment, hopefully in a moment. Now, okay, now it's done. First off, we have this paper 2D side scroller template, and the first thing you might see is we have a 2D representation in a 3D space. We can actually move in 3D space, but our objects are all in 2D. And that's because they are sprites. So that's the first big difference between a normal 3D side scroller and a sprite based 2D side scroller. Now, the first thing we need to do is to test out what we already can do. So just press play around it, and we can go from left to right, and we can even jump with the spacebar, but we can also jump with the W key. This is a problem because we want to use the W key and the S key for up and down movement. So in order to fix it, we go to the Edit section here, then select Project Settings, then go under Input under the Engine tab, select it, and then we will click this little Action Mappings button here, or this arrow button, and then go under the Jump arrow. We will go to the section W and delete it with this X here. Okay, so we already fixed one problem. Congratulations. So the next thing we need to do is, when we use the X mappings, which basically means we can go to the left and the right or up and down and such, we need to open it, or the X mappings here, and we just have to move right. But because it should have movement like Streets of Rage or Golden Axe, we need to add our up and down movement. So just click on this little plus button here and then type in move up down. We will use this button here, or this event here, to move up and down. So click on this none button here, then type in W and select the W key. Now we will click on this plus button a second time on the move up down button and then select the S key. So right now we have the W key for upwards movement and the S key for downwards movement. Now if you want to use a controller, a gamepad, a keyboard, the mouse or something else like Android, you just need to change the controlling schemes, and you can actually select a lot of different options. So just take the corresponding key to up and down movement and you will be good to go. Here's just one problem we will run into. We have both of these buttons or keys have the scale 1. That would mean if we press W, it will put out the scale 1, and when we press the S key, it will put out the scale 1. This is a problem because we will use the same movement of the W key or the S key. So we want to use the opposite logic of what the W key does, which is basically moving upwards. So in order to go downwards, we just type in a negative number. It will just make the opposite what this does. So it's a pretty handy thing here. When this is done, we can just close this, and when we press play, we will notice we can't use the W key anymore for jumping, but we can still use the space bar to jump. Cool. So here are two things how you could work this out with the kind of camera. You could potentially change the camera, so we have the Street of Rage kind of view, but this will basically not work in a sprite based environment. I tested it out. I can give you I could potentially give you a long explanation why it doesn't work, but it just doesn't work as well with a sprite based template. So to compensate for it, we need to tilt our world itself. Now tilting our world creates different kinds of problems, but these are easily fixable and will not be a problem in the long run. So first off, we need to delete all of this stuff here. We don't want to use the side scroll template, so we just select them and press the delete key and just delete all of these little bits because they are pretty useless for us. Then when we are done with it, we will go on to the object view here, then go on the basic, then go to the plane and just drag it in. We will place it directly below the feet of our character, like this. Give it a little bit room so our character doesn't get stuck. Drag it out and rotate it around 40 degrees. Now, if you want to scale things or rotate or move objects, you can use this button up here to move objects, this one here to rotate objects, and this one here to scale objects. You can also use the keys W for moving, E to rotate, and R to scale. Okay, so when we are done with adding the plane, which already has a collision, just click on this little button here, so we can see the subdirectories. Now, we will just right click in the 2D sidescroller BP because we just need the play material for testing purposes. So we just right click and select material and then type in plane mud. Just double click on it, open it up, and you will have the material editor. Now here you can specify a lot of different things like your materials, like Also some kinds of sprite-based behavior if you want to. But most of these options here are pretty useless to you. The thing is, base color utilizes lighting information. Because 3D lighting information doesn't work on sprites, they are not being accounted for because sprites use the emissive channel. So they are always directly lit and don't receive shadows. That's why sprites actually don't use any kind of 3D lighting informations. They are mostly already baked in. So the shadows are normally already added to the sprites itself. So we can just disregard the base color. We can disregard the metallic because this would just apply to physical properties, which is also being made inside sprites. Specular is the same thing, it doesn't receive any lighting information, so it's useless. Roughness too, because there's nothing wet or dry. It would also be baked into the sprite itself. But we will utilize the emissive color. This is the most important one. So if you work with sprites, use the emissive color one. Just right click in the material editor, type in constant 3 or 3 constant and select the constant 3 vector. This will create this little color node here. Just double click on it and drag the value up here to white. Connect these two to the emissive color and just save it. This will give us a normal white color. And the emissive color, what it actually does is, this is being used for glowing things and glowing stuff. So if you want to have glowy stuff happening, you can use the emissive color. Here's one thing, just if you use it in combination with UI elements or widgets, the emissive color will not work. It's just a limitation of the engine, it just doesn't work. But right now, the emissive color is actually for glowing things, and just a normal value of 1 is, it doesn't glow, it is just being, it just disregards every lighting information which is there. So if you don't have if you don't have a constant 3 vector, but rather a sprite or a texture or anything like that, just put or just connect the texture input with the emissive color. It's easy peasy. So then we can go out of the material editor, drag the plane material onto the plane mesh here, and we will get this nice white nice color. So if you then run, you will see it already has this kind of tilted landscape, but we need to implement our movement, our up and down movement, and that's what we basically need to do. So we will just click on the 2D sidescroller PP, then double click on the blueprints folder, and then double click on our 2D sidescroller character. This will basically open up our character blueprint, and when we go to viewport, we will have our sprite, which is being played, this component here, and it has already the source flipbook idle animation in it. So this is being played at the start and as the default value. We have the play rate here, which just means how fast should the animation play. So if we double it up, it will be much faster. Then we have the sprite color, which just means we can change our overall color of our character. Material should not be changed because it's a material basically just created for sprite based stuff. Physics enable gravity, yeah, it has gravity, or else we wouldn't be able to jump. at least not physically correct. Apply impulse and damage. We have our collision presets. And we have also a lot of events which basically fire off stuff if something is true or if a condition is true here. For example, unfinished playing means if the idle animation has cycled one time through the whole animation, it will fire off this event. You can just click on the plus sign and it will basically fire off if a certain event happened or if a certain condition is true. So that's how you get these nodes into the event graph. Then we have a lot of different events here. When we go into our sprite component, on component hit, when something collides with it, this will be activated. But if you want to use on component hit, you need to enable under collision simulation generate hit events. This one here. Or else this will not fire off. So next thing is on component begin overlap. So if the character overlaps with something, it will fire off this event. When the overlap, if you don't overlap anymore, it will fire off this event. On component wake has something to do with physics. So if the physics should do something, it's awake, and when physics are kind of disabled and don't do anything, they are asleep. So that's the difference between wake when they are active and sleep when the physics are inactive. Then on begin cursor over, if you have a cursor over, or if you have a cursor and you go over the player blueprint, this will fire off. If you go away from your character, this will fire off. On click, if you click on the player character, it will fire off this event. If you release the mouse button, it will show it will fire off the unreleased. On input touch begin, touch end, and touch leave are for Android devices and touch screens. So that's where they are used. And physics volume change, if you change the volume of your physics or your physics collisions, this will fire off. On component activated, so if the sprite component isn't activated at the start, but is later activated, this will fire off. And on component deactivated, if the component will be deactivated, this will fire off. So you have a lot of choice here. It can be a little bit overwhelming, but it has all its purpose. So just do baby steps. Okay, then we have our camera boom, which is just some kind of a implementation of a selfie stick. And our camera movement, or rather our camera, will always follow our spring arm component. So that's what the sprite or what the camera boom actually does. Then we have we just have a side view camera or a normal camera component on top of the camera boom. And then we have our normal capsule component, which is responsible for all kinds of collisions with the character. So nothing fancy here actually. Now comes the difficult thing. We want to move upwards and downwards. Because our level or our plane has a 40-degree angle and maybe even is more than 40 degrees. We will have problems running up because we have something in the character movement component which prevents us to get to a certain point if the slope is too steep. So just click on the character movement. I'm sorry for my dog, he's really antsy today. And then go down to character walking here, under character movement walking. Now you will find the max step height, the walkable floor angle, and different kinds of walk speed and speed crouch and deceleration. A lot of different things which you can tie around, but I will not explain all of them. The important thing we need to do is the walkable floor angle. We need to change it, because right now anything which is above 45 degrees cannot be traversed. So in order to fix it, because our plane is basically more than 45 degrees steep, we will put it to 90. So it will basically, or the character will basically be able to go up a 90-degree angle. The next thing, which will create a lot of problems, is when we still are under the character movement component and go down to planar movement down here, it will say constraint to plane. Because this normal side scroller template just goes to the left and the right, it is a good idea to constrain it to a plane. But because we have 4 directions where we can go into, we can't use the constraint to plane. You could use it possibly, but this is a little bit cumbersome to do, and it's just unlock it. Just uncheck the constraint to plane. And then we are good to go. Now, the last thing we need to do is to implement our character movement, at least upwards and downwards. Now, if you go into the event graph, we have a lot of different stuff here. These are all implementations of the character movement, which we have already seen. So I will go through them bit by bit, so you know what they actually do. The first one is the event begin play, sprite and set is replicated. The event begin play is always being started when the level starts. So that's what this basically do, or does. Set is replicated just means something for multiplayer, so if you want to use it in multiplayer, it will be set to multiplayer and it will be set to true. This references our target, which is our sprite, so the sprite, or rather the component which is referenced, will be replicated and will be shown on all multiplayer clients. That's what it basically does. So if you want to have a fun multiplayer experience over the internet, this is actually a good thing. So the next thing is we have our movement down here. We have our comments box called handle movement, and we have our move right button, or rather input axis. This one functions pretty straightforward. It just checks if we have axis value of 1 or -1. And here's the thing. We have 2 branches. The first one here and the second one here. The first one here checks if our axis value is greater than 0, so it goes into the positive. And because we had our scale here, like in our input, -1 and 1 and such, it will basically reference from 1 to the range of 1 and -1. So all things which are above 0 will be passed to the condition pin here. And this means if the branch, or rather if our axis value is greater than 0, we will fire off the true event. If it is not greater than 0, or if the condition is not true, it will fire off the false event. Now, the first true event will set a certain boolean and check it. A boolean is basically just a variable. You can create a boolean yourself by going to add new, select variable, and the first type you will have is a boolean. A boolean, actually, if you click on it, just distinguishes between two states, true and false. It cannot have any other condition. So a boolean is just a representation of on, off, and such. So what basically is happening, such a boolean is being set to true right here, and then the thing here, or our input, is being set to the add movement input. So our character is actually being moved. So the movement input here is just for movement of our character. Now we have a second branch here, and that means if this is false and our axis value is below 0, so it goes into the negative, it will fire off this boolean here and will pass in the add movement input. But also when it is false, it will fire off the movement input. So regardless of the states of these two booleans, it will always fire off your movement input. Excuse me. And the y direction just means, do we run into the x-axis, the y-axis, or the z-axis? And then we have a scale value, which is being fed from our move right input axis. So that's just plugged into it. Okay. Next thing is we have a jump button, and it will basically fire off the jump function. So we jump, nothing fancy here. Now we come to something like this, event tick. Excuse me. This will fire off this update animation by a frame basis. So every tick means every 0.001 seconds will this be executed. It will fire off an event called update animation, and if you want to create a custom event, just right click, type in custom event, and select add custom event. That's how you create a custom event. And if you want to call it, just right click, type in custom event, or rather search for your name and what you named it, and go on the call function and select custom event. And then you can just connect it. So basically update animation is a custom event, and it's being called every frame. Then, what does our update animation do first off? And it's up here. Our update animation gets the velocity of our character, which is basically influenced by the add movement input. So if we use the add movement input, we will get a velocity. This velocity will be converted to a float, which is basically just a comma number or a point number, and is not absolute. So we just have, it will just be converted to a float, so we can compare it and use it as some kind of a condition, because booleans are always red. And this basically means if our velocity or if our current velocity of our character is greater than 0, we will change our idle animation, which is already in here, to our running animation. So that's a pretty cool thing. Okay, so then we will have a return value, which goes into the new flipbook. So if it is true, it will change our flipbook, so our sprite, to a new flipbook, which is called running animation. So you can use this to change your flipbooks around and your sprites around. The sprite, which is our sprite component, is just the target for the flipbook. So we so we know which component we change. And that's what basically does. That's what basically the update animation does. Now, when we go down here again to the update animation, we will have something called a compare float. And this will compare these green values or these float values. The input is the break vector, which is just the same as this one up here, just that we break the x vector down, or rather the x-axis. So the break vector just takes it just breaks down our vector variable or our vector parameter and breaks it down to floats or float values. Then we'll compare it with the zeros or with 0, and we extract the velocity of our movement component, which we have here. So this is also using the velocity, which is also up here. It's the same stuff, just that I use this compare float as a macro. I won't go into that because it's a little bit more complicated. But basically, this is the is greater sign. So if our input, our velocity, is greater than 0, it will fire off our control rotation. And our control rotation means where is our player facing towards. So this controls where we are actually heading towards. It creates a rotator, which just sets it to 0 and zeroes it out. And then we have a is equal. If nothing is happening here in the velocity, it will fire off the branch event, a true and false, and is taking in our B is moving right, which we set to true or false here. So if it is true, it will set the control rotation to, but if it is false, it will set a different control rotation to 180, so it actually rotates our control rotation. That's basically for turning to the right side. So that's basically what all this stuff here does. Okay, now we will implement our down and up movement. First off, go to the handle movement comment or handle movement section, right click, type in move up down, which we created earlier, and select it, the axis event. Now we will do the same exact stuff like up here. We will basically copy this one here, or rather these ones, and the add movement component. Just copy and paste it down here. Connect it with a branch node. Connect the true with the add movement input, and the true with the add. Whoops! No. Forget it. First off, we need to specify in which direction we want to go. So we will use the axis value and connect it with the scale value of our add movement input. I will just test something out, so don't do it. I will just connect it directly to the add movement and see if it already works out of the box. Nope, it doesn't. Whoops. It does, but we need to change the world direction. We don't want to go sideways on the x-axis, so we need to put 0 in it. But we want to go up and down, so we want to change the y direction to 1. And then, yeah, you will see, oh, it is weird. It is really weird. We can actually use it, but our characters, or rather our inputs are inversed. So we can just delete the branches because we don't need them. It already works like this. Pretty good and pretty well. So the last thing we need to do is to actually invert the value. So just drag out from the axis value, type in times or star on the numpad, and then take this one here, float times float, and type in -1. And like I said before, when we change the input, -1 just does the opposite what the axis value or the positive axis value would do. So just put this times into the scale value and then play it. Now you will be able to go up and down, and it's working. I don't know what actually is happening down here, why it is cutting it out, and I don't know what this is actually, but it seems like maybe we have I think I know what it is. Go under project settings and then go under all settings and then go to the search bar and search for near clip plane. We have it on 10. So put it on maybe 1, and it shouldn't do this. It still does it, and I don't know why. Maybe if I put it back. Okay, I think I know what the problem is here. That's because our camera is here and we are kind of clipping into the plane itself. So in order to fix it would be to move it around, or just rather to kind of block our character from traversing into a certain direction. So to do that and to kind of restrain our character of going off the cliff or anything like that, we just drag in a blocking volume. So just go into this menu, type in blocking, and drag in the blocking volume. This thing is pretty handy. I don't know where it went. Okay, it went up here. Because it is invisible, but it provides basic collision. This is just to restrain our character, and you shouldn't use it for your sprites or for your sprite collisions. Now, if we just rotate it a little bit, scale it out a little bit, and then drag it up here and just move it, and just go to blocking volume, right click, go to edit, and then duplicate, and just duplicate it down. So we can't move past a certain point here. So if we use it, oops, okay, something weird happened. Let's see. It's like I'm bouncing off it. That's weird. I've never seen something like that. Okay. Yeah. Remember we changed the walkable slope line? So we can actually traverse it. So we need to put it like this. That way. Oh, I think we need to change it a little bit more. Yeah. So in order to fix it, we need to basically get this one here like 90 degrees and just drag our side scroller character down close to the button. So that way we won't get this clipping anymore. It's still happening because I didn't put down the blocking volume. So we get it a little bit closer to the character. It's still doing it. So maybe a little bit more. This still doesn't do it right. But we will change something. We will take a cube instead of a plane. And we will see if this works. Because I have the suspicion that the plane needs to be double-sided. So we will use a cube instead. Okay. I will just delete the plane because it might interfere. No, there's something really weird happening. It's cutting it out. I can't for the life of me say what it does or why this is happening, but I think it has something to do with the camera itself. Let's see if we find the culprit. I will just increase the target arm length. Yeah, it's a camera. So if you run into this problem with the cutout, just move or rather change the camera boom, at least the target arm length here, to around 1000, at least more than 500. And you will not run into this problem anymore. See? Cool. And we can also jump. And now it broke. So we need to change the blocking volumes because our jump actually interferes with our blocking volumes. They are too small for the jump, and that's why we are actually jumping out of it. So just go to our blocking volumes, scale it up a lot. It doesn't matter how much you do it. Like make like such a triangle, kind of a triangle out there. And then play. And then when we jump, it will work. So yeah. So that was it for the Sprite scroller, or rather the 2D side scroller example with the movement components. So this was it for the tutorial. I hope you liked it, and I hope it wasn't too confusing. But I needed to cover a lot of ground even for beginners or bloody starters, because it's basically a lot of stuff to take in. Now, if you want to see how you can create your own sprite-based systems, so you don't rely on the paper 2D systems, and you just want to use your sprites in a fully 3D environment, and you just want to have a challenge and basically create your own sprite-based stuff and sprite-based methods, you can contact me, you can comment in the YouTube section, and you can also PM me what you want. So if you want to see a sprite-based take in a fully 3D environment, just contact me and I will see if I can get it done in a timely fashion. I wish you a wonderful day, and I hopefully see you next time.